Okay, start.
Hello and welcome to this class. Today I will discuss the measures of variation. So far we have already discussed in the previous classes measures of center tendency, which includes the arithmetic mean, median, mode, geometric mean and harmonic mean. So now we start measures of variation. This is also known as, and you can say, measures of dispersion. So let us see what is the measures of variation. So before starting this topic, we just start. We take a simple example, and let us see the example. If we have a set of observation, suppose one set of observation, that is A, which includes the observation like 150 and 99. Suppose some other set of observation, that is B, which includes the numbers and data like 40, 50 and 60. And also take another set of data, that is 10, 50 and 90. Let us some more set of observation, and this is 49, 50 and 51. Again we take one more set of data, that is 50, 50 and 50. So here we have five set of observation, set of data, and one set of observation, that is the which include the 150 and 99. The second set of observation, that include the 40, 50 and 60, like this. So if we see these set of observation, what we will get? If you see 150 and 99, so it will give you total number of observation is 3. So we take n is equal to 3. Total number of observation 3. And if we find the center tendency, that is we just take arithmetic mean. So the mean of this observation 150 and 99 is nothing but mean is 50. Similarly, we see the second set of observation, and this includes 40, 50 and 60. Again we have number of observation, that is 3, and mean of these observations 50. So again the third one is, that also gives you n is equal to 3 and mean is equal to 50. This is also n is equal to 3 and mean of this observation 50. This one also n is equal to 3 and mean is 50. So we see here all the observation, the information from these set of observation are same. That is number of observation is 3 and mean is 50. So if we look at the set of observation, but the observation are different, but the information we extract from this set of observation are same. So information is what? The number of observation is 3 and their mean is 50. But you look at the each set of observation. First one is 150 and 99. The second one is 40, 50 and 60. Third one 10, 50 and 49, 50, 51, 50, 50, 50. So what is the difference? So here we see the difference is nothing but the distance from the mean value. That all observation, all set of observation having the mean 50. So here 50, 50, 50, 50. But the difference from the other observations from the mean are different. Here the other observation is 1 and 99, which is much more distance from the 50. Here 40 and 60, it is less variation with respect to first one. So here 10, 40 and 90. This is also some variation from the 50. Here 49, 50, 50. Here less variation. Means the other observation, the distance from the other of the distance of the other observation from the mean value is less. And if we see here, we get no variation, no dispersion, no scatteredness from the mean value. All are same 50, 50, 50. So we can say here we see there is no variation, no dispersion, no scatteredness, and in the other here there are some variation. This also variation, but variation are different in all the set of observations. So if we have only this information, this gives the average and some information about the set of observation, but this alone will not give you the complete picture of the set of observation unless until we know the variation and the uh, distance of the observation, each observation from their mean value. If we know one more thing, what more thing? That is the deviation from the mean value. Each observation, how distant the value lies from their mean value. So one more thing here we have to study, and this scatteredness, this variation from the mean value is also play a important role in our study. So the variation from these mean value and study of this variation is comes under the measures of variation and measures of dispersion. So in this topic we will study the variation and dispersion of the set of observation from their mean value. How the variations are, there are much more variations, sometimes there is no variation, sometimes there are less variation. If you see here, there is no variation because this is 50, 50, 50. If you see this set of observation, this is the variation, but this is less variation 49, 50, and 51. So their data are concentrated, much more concentrated. If you see here, there are more variation, more dispersion among the observation. So we also in our study the information about the variation. That is why we will study the measures of variation in today's class. So these variation can be computed through the various measures and method, and we are just writing here the different measures of variation, and these variations are computed using the given measures. And first we take the absolute measure, absolute variation, and second one is relative variation. Relative variation. In absolute variation, we find the variation of a variable. That will give you absolute variation, the variation in terms of the unit. And in relative variation, if we want to compare the variation in between two and more variable, then we will use the relative variation. If we just want to know the variation, we will use absolute variation. If we want to compare the variation between the two or more variable, so then we will use relative variation. So what are the absolute variation? So first one is range, and range can be computed by largest value minus smallest value. This is generally used in explaining the temperature, so maximum temperature and minimum temperature. The second one is interquartile range. Interquartile range. This is used for the ordinate data, and this can be computed using the formula Q3 minus Q1. Q3 is the third quartile, Q1 is first quartile. So difference between the third quartile and first quartile will give you the interquartile range. The next is quartile deviation. Quartile deviation, the formula is Q3 minus Q1 divided by 2. Fourth one is mean deviation. Mean deviation, and this is equal to 1 upon n summation mod x minus a, where a is any measure of center tendency. It may be either mean, median, and mod, and we will take the mod value. This formula is used for discrete case. We can also write the for continuous case, and for continuous it will be 1 upon n summation f into x minus a. The next formula we will use a standard deviation. So we write here the next fifth one is fifth one is a standard deviation, and this is very important measures of variation. A standard deviation, this is generally denoted by sigma, and the formula is 1 upon n summation x minus x bar whole square whole under root square root. For a continuous case, this is for the discrete case. Now you for continuous case, and this formula can also be, if you simplify this x minus x bar whole square, so this will also in simplification for this can be also written as 1 upon n summation x square minus x bar square. So either you can use this formula or this one for discrete case. This is for discrete case. Now for continuous case, means if the data are classified in frequency form, so this will be using frequency, and it may be written as 1 upon capital N summation f into x minus x bar whole square. If you simplify this like this, this can be written as 1 upon n summation fx square minus x bar square. So you can use either this formula or this formula in case of continuous data, for finding the standard deviation. And sixth one is variance. variance. And variance is nothing but the square of the standard deviation. So just you take the remove the square root and variance will be written as 1 upon n summation x minus x bar whole square in case of discrete, and for continuous case this can be written as 1 upon n summation fx into x minus x bar whole square. So this is the formula for variance. So variance is nothing but the square of the standard deviation. So we denote the standard deviation by sigma, and squaring this sigma square means variance. Now the some relative, this is the absolute variation which is used for just to know the variation of the variable. If you want to compare variation between the variables, you have to use the relative variation. And relative variation formula will be written as so in relative variation we use coefficient. So we use the formula using coefficient. So we have taken in absolute variation, we use the range. In relative variation we will use the coefficient of range. So first one is coefficient of range, and this will be formula largest minus smallest value divided by largest plus smallest value. This will give you the unitless value, and this is used for comparing the range of one variable to the range of another variable. Similarly, the coefficient of mean deviation, coefficient of quartile deviation, QD, quartile deviation. This can be Q3 minus Q1 divided by Q3 plus Q1. Where Q3, Q1 you already know, this is the third quartile, Q1 is first quartile. We have already discussed the last class, previous class. The third one is coefficient of mean deviation, MD. This is the mean deviation divided by A, where A is either arithmetic mean, median or mode. And the coefficient of variation, this will be standard deviation divided by arithmetic mean into 100. So these are the relative variation which is used to compare the variation between the given variables. So relative variation is always unitless, but the absolute variation having some units. So these are the formula which is used to find the measures of variation. Now we will take some numerical example. Suppose we have the data like temperature, and you can take another example of we have 6, 7, 9, 2, 5, and we want to find the range. So what will be the range? Range will be the largest value minus smallest value. So what is the largest? Largest is 9 minus smallest value 2. So the range of this observation is 7. And you want to find the coefficient of range, then coefficient of range is 9 minus 2 divided by 9 plus 2 means 7 divided by 11. This will give you the uniquest value, and you can use to compare with another one. Next example.
सर 10 मिनट के लिए हम जा सकते हैं.
Find mean deviation. Find mean deviation about mean, about arithmetic mean of the following data. The data is given like this. We take the data x and the 100, 102, 118, 124 and 126. So these are the value. X is given as 100, 101, 218, 124 and 126. Now we have to find the mean deviation about arithmetic mean. So here A represents the arithmetic mean, AM. So we know this is the discrete values. So in discrete value, we know the formula for mean deviation. Mean deviation is 1 upon n summation x minus a. A will be written as x bar because we have taken the mean deviation from about arithmetic mean. So this is the deviation from the arithmetic mean. So first find x bar, that is the arithmetic mean, then x minus x bar. So what will be the mean x bar? And the formula for x bar we know, this is summation x upon n. So summation x is, if you add this will be summation x is equal to 570. And how many observations? There are 5 observations. So mean will be 570 divided by 5. And this is 114. Now we have to find summation mod x minus x bar. So we take the x minus x bar here. We prepare the second table, second column, and we take the value x minus x bar mod value. Mod value means we take only the positive quantity. So x minus x bar, x is 100, x bar is 114. 100 minus 114, this is minus 14, but we take only the positive value, so this is 14. 102 minus 114, so this will be 12. 118 minus 114, so this is 4. This is 10. and this is 12. Now sum of these values, so this will be summation mod x minus x bar, and it will give you 52. So the mean value is you will get from this data, the mean is 1 upon 5 into 52, and this will be, I think, 10.4. Suppose the variable, the x is given in grams, so this is the grams, 10.4 grams. So this is the, if we want we have to find the mean deviation from median, then we have to first find the median of this observation, then take the deviation from the median value. If this is given like mean deviation about the mod, then we have to first find the mod of this observation. So this is the simple example of the mean deviation about mean. Now some another example. Next question, find mean deviation. Mean deviation of the following data. And the data is given. We will take the same observations, x, and the data is given like 100 to the same question we are using here, 118, 124 and 126. So the same example, from the same example we will find the mean deviation of the same observations. So mean deviation, not mean deviation I have already found. So we will find the standard deviation. Sorry. We have already obtained in the previous example mean deviation. Now we want to find the standard deviation. So first we know the formula. What is the formula of the standard deviation? So standard deviation is denoted by sigma, and of course the observations are like a discrete case. So using the discrete case, and the formula will be 1 upon n summation x minus x bar whole square root. This is the formula for finding the standard deviation. We have also discussed this formula can be written as, if we simplify this then this become summation x square minus x bar square. So either you can use this formula or this formula. So here we will use this formula. And the formula data is, we have to find first x bar. So we already find the mean of this observation, and this is summation x is equal to 570. So mean x bar is equal to 570 divided by 5, and this will be 114. Now take this here we have summation x square. So first prepare the table for x square. So this is x and find the square of this x square. You can also use this formula, the answer will be same. So if squaring this will be 100 square and 102 square of the 102, this will be 10404 and 13924 15376 and the square of 126 is 15876 and sum of x square and this will be 65580. Okay. Now putting the value, this is a square root 1 upon n is 5, summation x square is this is 65580 minus x bar square. X bar is 114 mean square of this. So this will be 12996. So simplifying this is 13116 minus 12996 and you will, after simplifying this, you will get 10.95 grams. So the answer will be 10.95. Okay. Now take another example. And the same question, if we want to find the variance, then what will be the variance? Just a square of this value, you will get the variance of these observations. More example, find a standard deviation of the following data. Find a standard deviation of the following data. Here we have the frequency distribution. So we take the data x with their frequency f and the value is 3, 4, 5, 6, 7 and its frequency is 4, 6, 15, 15 and 10. So this is given in the group data. So we will use which formula? The formula will be used like 1 upon n summation fx square minus x bar square. This is your formula. This formula is for group data. So here first find the mean x bar whole square. So first find mean, and we know the mean in group data. Mean will be summation fx upon capital N. So first find fx. Fx, and again here you see the summation fx square. So we also this data. So first squaring x square, take x square, then multiplied by f of x square, and this will give you summation fx square. So we just compute this data, this calculation from the our questions given value of x and f. So here's the find fx. Fx is what? This is 12. This is 12. This is 24. This is the 75, 90, and 70. F into x. Then squaring x squared. Squaring this observation x. So x square here 3. This will be 9, 16, 25, 36, and 49. Then multiplied by f. X square multiplied by f. So x square and f. 4 into 9, 36. 16 into 6, 96. 15 into 25, 375, and 15 into 36, 540, and 10 into 49, 490. So just obtain all the term, and sum of these, sum of fx is 271, and here sum of fx square, this is 1537. Now find first mean, and mean will be summation fx divided by n, where n is nothing but the sum of the frequency, and sum of the frequency, that is capital N, this is 50. So summation fx is equal to 271 divided by 50. So mean will be 5.42. And once you get the mean, arithmetic mean, now find the standard deviation. So standard deviation is 1 upon n. 1 upon n means 50. Summation x square, summation fx square is 1537 minus x bar square. X bar is 5.42. The square of this 5.42, squaring these. Now after simplification you will get the value of standard deviation is 1.16. This is the value of standard deviation. This will have some unit. Suppose x is given in gram, so standard deviation is 1.16 grams. Mean actually this, what does it mean? 1.16. This is the average difference from the mean value. Now we take some continuous data with the class interval. Suppose to take another example, and the data is given in the class interval with their frequency. So class interval 2.5 to 3.5, 3.5 to 4.5, 4.5 to 5.5, 5.5 to 6.5, and 6.5 to 7.5. And their frequency is 4, 6, 15, 15, and 10. So there is some variable which is given in the class interval 2.5 to 3.5, 3.5 to 4.5, and so on, with their frequency 4, 6, 15, 15, 10. Now we have to find the standard deviation of this frequency distributions. So we will use the same formula, and for this we have to obtain the summation fx square. So first find the mean, and we have to find the fx. So what is the x, because the variable is given in the class interval, so we find the mid value of that class interval. So the mid value of 2.5 to 3.5 is 3, 3.5 to 4.5 is 4, 5, 6, and 7. So this is the mid value of the class interval x. Now again, what we will need, our need is to find the summation fx and summation fx square. So find fx, and for fx square you just find x square and then fx square. And you can also, I think, the same observations as such the previous you have. So fx is what? F into x, 12, 24, 75, 90, and 70. What is the x square? X square is 9, 16, 25, 36, and 49. And fx square is 36, 96, 375, 540, and 490. So you will get the same. This is the same example as we discussed the previous, but in that question we have already taken the x. Here we have taken x in terms of class interval. So this is the same example, and you will get the x, that is the mid value of the class interval. And you can also, the same process you can apply. Now take one more example. The scores of two batsmen A and B in the series of 6 matches are given below. So here the score of batsman A and here the score of batsman B out of 6 matches. The score of batsman A is 15, 12, 10, 20, 25 and 10. The score of batsman B is 16, 18, again 16, 12, 10 and 15. These are the scores of two batsmen, player A and player B, you can say, and these are the score of out of 6 match series of the 6 match. Now you have to find which batsman is more consistent and more reliable. More consistent oblique more reliable. So these are the scores of two batsmen are given here. Now you have to find which batsman is more consistent or which more reliable. So for finding the consistency, we have to see which batsman has less variation. Less variation will give you more consistency. So just we take a simple example like two batsmen A and B, and score for batsman A is 10 and 90. Here the score of batsman is 40 and 60. So you see that both are both having 100 marks, 100 score in two matches, but the distribution of score is 10 and 90. The batsman B also score 100 total, and the distribution is like 40 and 60. You can also see the average, both the batsmen, average of both the batsmen are same, 50-50. But which batsman is more reliable? So you just see here is the variation from the mean value is maximum. Here the variation from the mean value is less, minimum. So obviously this will be more consistent. So if variation is less, means the data is consistent. So the same process we will see here, and we will use for this example relative dispersion or relative variation, and this is given in the standard deviation. So we will use the coefficient of variation. So in such type of question, we will use the coefficient of variation, and we already have the formula coefficient of variation CB. This is standard deviation divided by mean into 100. So we will find the coefficient of variation for each batsman, and whose coefficient of variation is less, that will be more consistent. So what is the formula? We have to first find the standard deviation and mean of each player. So just we denote the score of batsman A is denoted by X, and the score of batsman B is denoted by Y. So X is the score of batsman A and Y denotes the score of batsman B. So first find mean and standard deviation. So mean of X bar is summation X divided by N, And for another player, we will find the mean of y, that is summation y divided by n. And similarly, we will get the standard deviation for each batsman. Now see here the what is the mean, and also we will find the standard deviation. So standard deviation for the batsman x, and it will be obtained by using this formula 1 upon n summation x square minus x bar whole square, and standard deviation of y will also get by using 1 upon n summation y square minus y bar square, because we have taken x is the score of batsman A and y is the score of batsman B. So we just find mean and standard deviation of both the players. So for getting the mean, we just see what is the summation x. Summation x is total score of player A is 92 out of 6 matches, and the score of player B is 87. So mean x bar is 92 divided by 6, and it will be 15.33. 15.33. And mean of player y, and this is summation of y, that is 87 divided by 6, and this will be 14.5. So this is the average score. Average score of player A is 15.33 and average score of player B is 14.5. Now find the standard deviation. We have to obtain x square and y square. So what is the x square? X square is 15 square, 225, 144, 100, 400, 625 and 100. And y square 16 square, 256, 18 square, 324, 256 and 144, 100 and 225. Now sum of x square, sum of these, this is 1594, and sum of y square, this will be 1305. So now we find the standard deviation for each score. So standard deviation of x means the standard deviation of the batsman A, and this is 1 upon n summation x square minus x bar square, and this is 1 upon 6 summation x square is 1594 minus x bar square. X bar square is 15.33 square. So after solving this, you will get the value of standard deviation x, and after solving this you will get 5.53. Similarly, the standard deviation of y, and the formula is 1 upon n summation y square minus y bar square, and this will be 1 upon 6 summation y square is 1305 minus mean of y. Mean of y is 14.5. 14.5 square of this. After solving this, you will get the standard deviation of y is 2.69. Okay. Now find the coefficient of variation. So we write here the coefficient of variation for player A. Okay, we just rub this, and now the coefficient of variation for player A, coefficient of variation for the score X, and this is standard deviation divided by mean. Standard deviation of X, this is 5.53, or you can write the standard deviation of X divided by X bar into 100, and the value of standard deviation of X 5.53 divided by mean is 15.33 into 100, and the value will be 36.11. This is taken as in percentage, so we can write there 36.11%. And for standard coefficient of variation for the batsman B, and this can be computed coefficient of variation for score Y. So this is standard deviation of Y divided by mean into 100. This is the formula, and put the value standard deviation of Y 2.69 divided by mean of Y 14.5 into 100, and this will give you 18.56%. So just see here two values, coefficient of variation for X and coefficient of variation for Y. So we have the coefficient of variation for X 36% and coefficient of Y 18.56%. So which will be less? Obviously the coefficient of variation X, coefficient of variation for the score X is less than the coefficient of variation for Y. So you can say that the X has less variation, means the batsman, player B, coefficient of X, no, 18, that is the 36 and 18. So coefficient of variation for Y is less than coefficient of variation for X, right? So coefficient of variation for Y is 18%, which is obviously less than the coefficient of variation for X. So we can say that player B, that is the batsman B, is more consistent than player A, because of batsman B or score of batsman B has less variation. So using this comparative study, we will use coefficient of variation. So you can say the batsman B is more consistent than player A. But the one more question in this example, which batsman is better? Consistency is another thing and betterment is another thing. If you see which batsman is better, so you have to go for their mean value. So if you see the mean value, so mean value is average score of batsman A is 15.33 and score of batsman B, average score of batsman B is 14.5. So batsman A's average is better than the average score of batsman B. So you can say the batsman A is better than the batsman B, but not consistent. Batsman B is consistent batsman, but batsman A is better, and you can say good batsman. His score is good because his average score is better than more than the average score of the player B. But player A is a good player but not a consistent. But player B is not a good but he is consistent player. So this is the analysis of two batsmen on the basis of their score. So remember it. The best batsman is computed by their average score, and consistent batsman will be computed by their coefficient of variation. So now the next we will have next topic, and now the some properties of standard deviation. Properties of standard deviation. First property is the property of standard deviation and variance are same. So either the property which properties is applicable for standard deviation, they can also applicable for variance. So here we have taken only standard deviation. So first property is standard deviation is independent of change of origin, not scale. We have already discussed the origin and scale. So if we change the origin, standard deviation will not change. If we change the scale, standard deviation will change. And also we obtain the combined variance, combined standard deviation. Combined standard deviation means if we have more than one set of observation and whose informations are given, then we can combine as a one. So the formula for combining these can be written as standard deviation. Suppose we combining two set of observation, and the formula is n1 sigma 1 square plus g1 square plus n2 sigma 2 square plus d2 square divided by n1 and n2, where d1 d2 is nothing but this is the combined mean, difference of x1 bar minus x12 bar. So this is the combined standard formula of the combined standard deviation. And for example, standard deviation is independent of change of origin and scale. You can see if we have original variable x, and if we change its origin in scale, how to change origin? Just subtract and add with a constant, and scale by dividing and multiplying by a constant. So if we take x minus a constant e, it means change of origin, and divided by a constant h, so it is change of scale. We just here we are just proving this property. So now we have the new variable, and this new variable is written as u. So our original variable is x. After changing its origin and scale, it becomes the new variable. The new variable is denoted by u. So here we can say that x is equal to a plus hu. You can write, after simplifying that, x is equal to a plus hu. Now taking summation both side, this will be summation x is equal to sum of a is constant, it become na plus h constant, this is summation u. So just suppose this is equation 1 and this is equation 2. So 1 minus equation 2. So it can be okay. Now in equation 2, we just divide by n. If we dividing by n in equation 2, multiplied by 1 upon n both sides, it will give you summation x by n, and this is n a divided by n, this is h summation u divided by n. If you see, this is summation x upon n, this is nothing but me, and here we get n cancel a, this is summation u divided by n is nothing but mean of u. So this is the equation, we get equation 3. Now subtracting equation 1 minus equation 2. Equation 1 minus equation 3. Equation 1 minus equation 3, you will get x minus x bar is equal to a cancel h comma u minus u bar. We will get this difference of equation 1 and equation 3. Now squaring both sides. Squaring both sides. So this is x minus x bar square, and here h square, u minus u bar square. Now taking summation both sides. Summation both sides. So this become x minus summation x minus x bar. This is constant summation u minus u bar square. Now taking again dividing by 1 upon n, multiplied by 1 upon n, it will be 1 upon n summation x minus x bar square and h square summation 1 upon n and u minus u bar whole square. Now taking the square root, you will get 1 upon n summation x minus x bar square, here h, and 1 upon n summation u minus u bar whole square. So here this is nothing but this is the standard deviation of x is equal to h times this is the standard deviation of u. So where x is our original variable and u is after changing its origin in scale. So the difference is a, we have taken two constant A and H, where H is subtracted, that is the change of origin, and H for change of scale. So there is no change of origin. So only the role will play the change of scale. So if you change the scale, the standard deviation will change. If you change the origin, standard deviation will remain same. So this is the what we have to discuss today, and now I stop here, and we will see the next topic in the next time. Okay, thank you.